or Vishnu Devineni.
Yes,
Or,
Ganesh.
yes,
So, am I audible?
yeah, we can able to hear you.
Yeah. So, I'm having 10 years of IT experience. So, last 5 years, I'm working as a AWS Cloud. I'm basically from a admin guy, Oracle DBA, and Postgres, MySQL. So, these are my core skill set. So, I want to learn advanced technologies in AWS. So, that's the reason only I went to your thing and found that it is suitable for my job role. So, that is my plan to join, Ganesh. Yeah.
Okay, thank you. Azim?
Hello, I am Hazim from Egypt. Um, I am data analyst and I have good background in WOS, but I need more experience and hands-on in it. I looking forward to work as a data engineer using Amazon platform.
Thank you. Naresh?
Hello.
Yeah, Naresh, we can have it hear you.
Yeah, I have 5 years of IT experience, and it's completely different ATL related Informatica data stage on talent. I am new to in AWS.
Okay, got it.
Yeah.
Jayant?
Yeah, can you hear me?
Yes, we can.
Yeah, I'm Jayant. So I'm a recent graduate from Arizona State University. So I am a specialization in data engineering. So I would like to add up AWS with the data engineering school so that I can secure a job in the IT sector. Okay.
Okay, got it. Rakesh?
Hi all, my name is Rakesh. I'm having totally 10 plus years of experience into database administration and across DB migrations, as well as Aurora PostgreSQL migrations from Oracle to Aurora PostgreSQL migrations. I need to improve myself in technical wise data database administration into other AWS databases like Redshifts and other things. Okay, database administration to AWS side. Okay, that's the reason why I joined all this. Thank you. Thanks for the opportunity.
Vishnu?
Hi everyone. I'm currently pursuing my master's in data science. Uh, Apart data science, I would like to gain knowledge in data engineering too. So that's why I joined.
Okay. And Vishnu Nair?
Hello, yeah. So actually, I'm graduated from University of Bridgeport. I'm a recent graduate trying to get into the career of data engineering. So trying to make up some skills on AWS as well.
Okay, got it. And Karthik?
Yeah.
Karthik, can you hear me? Okay. And Vijay? Vijay, can you hear us? Vijay Kumar. Yeah, Jalaj, you can go ahead.
Thank you, Ganesh. Thank you all for your introduction. My name is Jalaj, and I'm working as an AWS engineer with my company currently. I'm working in this data engineering field from since last 8 years around, and I work on technologies like Python, Spark, Snowflake, Redshift, AWS services such as Glue, Athena, Lambdas, S3, IAM. I'm a professional in creating data pipelines, data architectures, designing the pipelines and executing those. And I'm providing these trainings with Ganesh from last more than 1 year. So I'm just going to share my screen. And yes, I'm also certified with AWS Solution Architect certification and AWS Data Analytics specialty. So just a second. Yeah. So first of all, I will take initial 15, 20, or maybe few minutes to walk you through the course content, and then we will start with the classes today itself. Yes, this course is going to be AWS Data Engineering course. Here you are gonna learn about data engineering technologies which are emerging right now in the market. We're gonna be capturing we are going to be starting with Python. Sorry, we are going to be starting with a cloud introduction. Okay, in which we will discuss about the benefits of the cloud, what is cloud, how it is built, how it is works behind the scenes, what are the data centers, what are the regions, those very element level basic details we are going to discuss there. And then we're going to start with S3 as our storage layer of the cloud. We will learn the features of S3. We'll see its functions such as storage classes, lifecycle rules, its triggers, its security, versioning, and all those details we are going to see here. Once we are completed with our S3 part, we are going to learn IAM, that is one more security service in the cloud. After IAM, actually, we are supposed to start with AWS Lambda functions. So in this course, actually, we will use Python as our programming language. And it is possible that many of us, it does not know Python or don't work on Python. So before starting with Lambda functions, because we are going to write these Lambda functions in Python language only, we are going to learn Python first. I'm going to cover how to write some Python codes, Python data types, lists, dictionaries, arrays, data frames, how to modify data using those things, how to write queries on top of Python data frames, introduction to DuckDB, and all those features we are going to see here. Once we are, a bit confident with Python, like I will be covering enough Python to, get started yourself in the data engineering field. We are going to cover Lambda functions. Here we will write some codes that are going to perform. It's like Lambda is a tool that works on microprocessing architecture. And here, this Lambda functions we usually use to orchestrate our pipelines in the real time, converting our ad hoc tasks into automated tasks. So those processes, those task automations, those pipeline orchestrations, Lambda functions features, how to approach writing a Lambda functions, what is the users of Photo3, and some those details we are going to do hands-on here. We are gonna cover two or three different examples coming out from different scenarios in the Lambda functions. And then on the later stage, we are going to have a mini project based on Lambda functions that is going to be close. That is going to be actually taken inspired from a real-time scenarios. Okay, and then we are going to discuss AWS Athena. So Athena basically is an analytical tool. Here we can go ahead and write SQL queries. So we will see its features, its use cases, how we do create tables, how we make this process automated, how to use Glue crawlers to interact with Athena and create tables, and how we can go ahead and actually query these tables. In which use cases, in which scenarios we should use Athena, in which scenarios we could have skipped Athena and use some different things. Then we are going to learn about AWS Glue. This is where we are going to spend most of our time, as AWS Glue is the heart of the ETL process or the data engineering process that we do on cloud. AWS Glue helps you. AWS Glue helps you doing data transformations. All your logics or your analytical queries comes here. And you have multiple options with the AWS Glue. We can use visualized jobs to drag and drop and GUI-based tools to do data transformations. Then we do have Python shell to go ahead and execute our Python codes to do data transformation. Then we have Spark shell also. Spark is a technology that is built by Apache. And we do have a Spark shell here also that is going to help us write PySpark codes. And as I mentioned, the PySpark, we are also gonna learn PySpark here. So again, 2, 3, or maybe 3 days we are going to spend here learning the PySpark syntaxes, comparing the PySpark with SQL, comparing the PySpark with Python data frames. Those things we are gonna cover here. Okay. Once we have adapted ourselves to write some Glue codes, write some data transformations using Glue codes, we are going to move ahead and work with a pure analytical part, that is AWS Redshift. I'm going to introduce to you with Redshift, its core architecture we are going to discuss. We are going to discuss that how the data can be distributed between various of Redshift nodes, its workload management, its DDLs, DMLs, how it achieves a massive parallel processing, what is Redshift Spectrum, how we connect Redshift Spectrum to S3 tables, encodings, data compressions, how to load data, how to unload data, how to create user-defined functions, how to create some procedures. It's sorting short columns, it's indexing, all those things we are actually gonna see here in the Redshift part. Redshift is actually a competitor of Snowflake, so we are also gonna discuss Snowflake a bit here. And the latest stage, I'm going to introduce to you with Amazon EMR, that how we can create a Hadoop cluster in the cloud and connect to that and run our PySpark or Spark codes there, how to use EMR for our data transformation. So we can say EMR and Glue is a kind of a, they go hand to hand, like they're trying to solve the same problem, but still they have a different use cases, different scenarios where to use one of these. We are going to compare that scenarios. Sorry. Yeah. Then we are going to discuss, like we are going to be moving away from like normal traditional databases, data warehouses to very new, attractive Amazon DynamoDB. That is a NoSQL database in the cloud. We are going to discuss its features, its use cases, various kind of indexings that we have in the DynamoDBs. How do we create tables? How do we insert values in the tables? It's consistent, smooth. Some hands-on practices we are going to see here. So something very new and something very interesting thing we are going to learn here, okay, with the DynamoDB tool. Then in cloud, if you have seen the cloud technologies, we have multiple things there. So we are going to learn IAM, RDS, and actually Kinesis we are going to cover completely. We are going to cover Kinesis data streams, Kinesis data firehose, Kinesis data analytics. And with all of these 3 tools, we are going to perform some live data processing. Obviously, this is going to be a sample basis, but we are going to perform hands-on demos with live data. I'm going to show you how we can write producers in the Kinesis, how to write consumers in the Kinesis, how to do data transformations on the live data using SQL analytics, or how to do data modifications using Lambda functions over Kinesis data firehose. All those things, like again, around 3 to 4 days we are going to spend here on the Kinesis part also. Going to discuss the differences between live data processing, batch data processing, which is a better one, or which kind of scenarios are, or which kind of scenarios are supposed to be for live data or batch data, that we are going to discuss here. We will be discussing, like in the meanwhile in the course also, we are going to be discussing about KMS, CloudWatch, SNS, secret messages, secret measure of cloud. So all those things we are going to see. Then we are going to finish this course with a complete real-life based end-to-end data pipeline. We are going to be storing our data on S3s. We are going to be trigger our pipeline based on the Lambda functions orchestrations. We are going to be doing some data transformations in the AWS Glue. We are going to be performing slowly changing dimensions in the AWS Glue. We are going to convert our final data frames into Parquet files and load those into Redshifts. And then, make those tables available in the Redshift for your BI tools, maybe machine learning tools and all those things. So this course we are going to finish with a complete end-to-end data pipelines project. And while we are going to discuss the Snowflake, I'm also going to tell you that how we can go ahead and use AWS Glue to connect with Snowflake and run some queries there and make your process automated. So this is the course content that we are going to offer to you. Yeah, if you have any questions, doubts, please do let me know. Hello, am I audible?
Yes, sir.
Yeah, you're audible.
Yes, yes.
Actually, I mean, if you have any sort of questions, doubts about the course content, about the tools, technologies, you can ask me. Otherwise, we are going to start with the introduction of cloud.
No doubts.
Okay, so I mean, if you guys ask no questions, I'll assume that you are absolutely clear. You have no doubts. Okay, this is going to be same for the future classes also. So if you have any doubts, questions, issues, please raise your voice. Please do ask those questions. I'll just wait for 1 more minute if you have any questions about the course content. Okay. Otherwise, we are going to start.
Will we work on real-time projects?
Okay, when we talk about real-time projects, it's not possible for me to, assign you some actual production project. But the project that we are going to create at the end, it is inspired from an actual project that I have created in my company. That is going to give you quite a good knowledge about how things happens in the production. So you can write those into your CVs for future interviews, or if you are working existingly on the cloud, also that is going to help you out there.
Okay, thank you.
Any questions? Vishnu, Nair, Satish, Rakesh, Naresh, Karthik.
I am good.
Yeah, actually, I'm having actually. So is this course is covered will be covered DBA part 2, I mean database administration task 2.
So, okay, we are not covering any administration side of activities. This course is completely focused on the data engineering guys. So if you are a DBA and if you are interested in learning data engineering, then yes, this is the course for you. But if you are looking to enhance your knowledge in the data administration field itself, then I'm sorry, then we are not focusing on the admin side of activities.
Okay, database engineering means data engineering, not database engineering, right? Data engineering. So okay, transformations. We have to do with the transformations, all those things from on-premise database to cloud. Is that ETL tools, using ETL tools?
Yeah. So on-prem to cloud, we do have some knowledge sharing session about those things. But as I do not have any data centers that I can show you that how we can migrate those things. Okay, so again, I will not commit here that I have no data centers to actually show you to migration of the data. But yes, all the extractions here actually basically means 90% of time, our Glue jobs or the source is S3, from where we actually extract our data. Then we do transform the data using the AWS Glue and load that into mostly it's either Snowflake or Redshift.
Okay. Okay, thank you.
Okay. So we will start with the lecture of day. Okay, so yeah. We will be starting with the concepts of cloud engineering, and today, I mean, I do write AWS services here, but most of the concepts that we are going to discuss here are same for all the cloud providers. Okay, that means Microsoft Azure, Amazon's AWS, Google's GCP. All these, or you can say, share the same architecture that we are going to discuss today's class. Then from tomorrow onwards, we are going to be starting specific to AWS part. And I'll be comparing these clouds in future classes also. So basically, all the services that I have shown you now or introduced to you now, like the S3s, Glue, or maybe DynamoDB. So we do have counterparts available in the Microsoft Azure. So it's like if you learn AWS engineering concepts, then concepts are actually same on the Azure side also. It's just that their look and feel, the features, and the tools names are different. If I give you example, we have a S3 here, and then those guys have Azure Blob Storage. We do have DynamoDBs here for NoSQL data processing, and Azure has Cosmos DB for the NoSQL data processing. AWS has this Redshift, and Azure has Synapse. So like that, the concepts, the ways, you can say it's like 80% same. It's just the 20% difference comes in the look and feel. Some of the features or the costing and all those things are different slightly. So yes. First of all, what does cloud computing actually means? So if I talk about my experience, like when I was okay, I started my career from the mainframes. Okay, I'm not sure how many of you knows this mainframes, but I started my career from mainframes. Okay, and I went for trainings like you are coming today. I went for trainings. I was in Pune, and for like 1.5 weeks or 2 months of training I did. And then I wanted to practice whatever I have learned there, POCs or whatever. I have wanted to practice those things. And there were no Hadoop clusters. I actually went for Hadoop trainings, and we had no Hadoop clusters at those time. Okay, because it was quite an expensive infrastructures to install. Even when I asked my company that can we have a Hadoop cluster for our practice, they denied. And this is just a personal experience. Now, if I talk about the actual company's level experience, let's say my company after 1.5 years or 2 years moving away from mainframes to maybe some technologies, maybe like Hadoop. Okay, so around I still remember around for 2 or 3 or 4 months at least, we were just discussing how many nodes of cluster we will need, how we are going to install the cluster, how we are going to purchase, how we are going to make sure that client is passing the budget, how we are going to convince them to pass the budget. Cause of this discussion was that Hadoop was very expensive. Once we purchased that, we had to show that it's proving beneficial for us, and lots of other questions was there. But just 5 years fast forward, if I talk about today's time, we have cloud computing available. Now, if I want Hadoop cluster for a practice, maybe as a personal user, I can go on AWS, I can launch EMR clusters, and I will be paying around 70, 80 rupees per hour, maybe even more cheap if I, optimize that. Let's say 50 or rupees per hour. So I don't think it's a bad idea that you just use that cluster for 3 or 4 hours and pay 200 rupees, and you got actually really a real life experience. This is for personal, and again I've talked about organizations. Now organizations are not wasting their time of 2 or 3 or 4 months in brainstorming at how we can plan the infrastructure. If in today's time, if you have some idea, if I talk about my company, I work for a consulting firm. Okay, and these guys have a lot of POCs going on. So now we guys don't think or worry about the infrastructure part or getting the approval of budget or all those things. We just get idea clicked in our mind. We do few clicks on the cloud consoles. We rank those resources and we start using those resources. So same thing actually happening in the production level environment also. So now cloud computing, you can say it's a on-demand delivery of IT resources over the internet. That means as and when you need some infrastructure, as and when you need some resources, you get those resources, you don't purchase those resources, and you only pay for the resources for the minutes of time you have used. So if you have used something for 60 minutes, you're going to be paid for 60 minutes. And if you have used something for, let's say, 2 hours, 3 hours, you're only going to be paying for 2 hours only. Okay, so instead of buying, owning, and physically maintaining those data centers, servers, or whatever resources that we are going to purchase on clouds, with few clicks, within few seconds or minutes, we can get those resources deployed for us. This is the power of cloud computing. Now the vendors available in the market are Microsoft, GCP, AWS. You can choose any one of these as per your convenience. So what are the benefits of this cloud computing? Benefits come as such as agility. Agility refers to the same concept. Like we are not waiting for 3 months to just get started with our actual idea implementation. From day one, if that idea gets approved from day one, we can start working on the real implementation. Instead of thinking and worrying about that part, we can just go ahead and start worrying about our actual implementation. This can be agile. That means if we need some less capacity in starting, we can have less capacity and paying less amount. And if we need some momentarily, if we need some higher capacities, we can purchase the higher capacities, pay for the higher capacity amount, and again get back to your lower capacities just in case if you have that kind of requirement. So it's kind of a very agile. Okay. And yes, we have cost savings also. We no need to purchase. Again referring to same examples, like if we have to purchase a Hadoop cluster and then just think that client denies or that project gets scrapped or something happens that we cannot utilize our Hadoop cluster, it's just a wastage of cost, resources, and time. Those kind of problems we do not face on the client or on the clouds. If something goes in the scrap, we can simply go on cloud and stop the resources, and we are not going to get charged over for that. No need to waiting for months. We can be quick and fast. We can be deploying our resources in minutes. So I'll just take a pause here. If you have any questions about cloud computing or its benefits, you can ask those questions. Otherwise, I'm just going to continue. So this is going to be a format of this course. I'll be taking 1 or 2 topics. I'll describe about those things if I'm doing hands-on. So 80% of the time, we are going to be discussing these things on the actual demonstration site. It's not going to be PPTs or documents. Okay. And if you have any doubts, questions, you are welcome to interrupt me and ask those questions. No need to wait for me to finish this. And when I stop and when I give you time, you can think about something. If you have any questions in your mind, you can just come back to me, ask those questions. Even after the class, if you have any questions, you can raise those questions, ask me. And even after the course, while you're doing some practice, while you are maybe went for some interviews or doing something, and if you have questions, doubts, or issues, we will be having a WhatsApp group. You can ping me and we can connect and discuss and clear your doubts. So yeah, if you have any questions about this cloud introduction and benefits.
No.
Hello. Jitin.
Yes.
Yeah, Jitin. So I have a question on the course structure. So will you be teaching the CLI, like command line interface, to use the AWS, or it would be all UI?
It would be all UI. Yeah, it will be all UI. At one or two demonstrations, we have used CLIs also. Actually, for businesses, we have used CLIs, but I won't count that demonstration as a core thing. Okay, I will say that we are using UI only.
Okay. So by your experience, like in most of the industries, does they use CLI as a data engineer, or it would be more on UI?
See, if I talk about DevOps guys or admin guys, they are mostly on CLIs. If I talk about engineers, we mostly use UIs.
Gotcha. Yeah, thank you.
Yeah, welcome. Okay, so if you have no questions, I'll just move ahead. Okay, so then basically the resources that we rent from the clouds, okay, we can actually divide these resources in three categories. And we should understand this, like these are the very basics that I'm going to discuss today, okay? But I always say if you don't know basics, we cannot go ahead and master ourselves for the complex things. So yeah, one of the basic things or basic terminologies that we use in the cloud computing, be it DevOps, be it data engineers, be it machine learning guys, be it just admins, be it just cloud engineer guys, or maybe architects. It's these three terms. Those are infrastructure as a service, platform as a service, and software as a service. So let's understand the difference between these three terms. And these terms are actually true, again, for all the clouds, be it AWS, Azure, or GCP, or any cloud that we have in the market today. So the resources that we take from the cloud services, if I take some resource, okay, let's say if I rent some virtual machines, I'm not sure how many of you have actually seen the consoles of the clouds. Maybe let's refer to AWS only from this point. Okay, so we have varieties of services such as we have virtual machines, we have storage, we have databases, data warehouses, NoSQL DBs, we have machine learning services, we have IoT services. So let's say we pick a virtual machine. That means I might go ahead and launch a EC2 engine running a Linux machine for me. Okay. Now I own that Linux machine. That means its security, okay, security in the sense of it's not physical security that will be taken care by AWS. It's software security, who can access that machine, who cannot access that machine, it's networking, it's patching, it's OS upgrades, what tools I'm going to install on those machines, how I'm going to use that machine. Maybe I want to install a database over that machine. Maybe I want to install some containerized application on that machine. Maybe I want to install some software applications on that machine. That is completely up to me. This means cloud offered me some infrastructure. That means cloud offered me a machine. Then on that machine, I'm open or free to utilize that machine as per my requirements. That means I could have gone ahead and used it for database management, used it for software development, or used it for just gaming also. And those, like it's me who is going to decide how I'm going to use that, how I'm going to maintain that, how I'm going to upgrade that. Okay, who can access those things? It's completely depending on me. Then these kind of services where we actually have the full control over the services are called infrastructure as a service. That means We are just going to get infrastructure from the cloud. Then how to use that infrastructure is completely the responsibility of a user of the cloud. Okay. Then in the second category, we do have platform as a service. This means I'm renting something from the cloud that is predefined, its use cases and its users and its features. Okay. For an example, if I talk about, we do have a platform as a service, AWS Lambda functions. Okay. So we are going to get a platform where I will be able to run my Python codes. Okay. We do have multiple language support. That means we have 6 language support as of now for Lambda functions. And on that Lambda platform, I can go ahead and write my program. But here, I cannot install a database. I cannot store something. I cannot choose a version here. I cannot upgrade. I cannot downgrade. I have no options for security patching or OS upgrades. All that I have is I have a platform where I can run my codes. What code I'm going to run, that I'm going to decide. What is the logic of that code? What is the purpose of that code? What I'm going to achieve that with that code, that I'm going to decide. So I do not have the complete control over the infrastructure. That means I just have a platform that I can use for my logic building. These kind of services are called platform as a service. Okay. Then the third category is most easy to understand. This is software as a service, where cloud gives us a software that we can simply go ahead and use. Software means maybe a Microsoft Teams, maybe Zoom, and same way AWS has Chime, that is connectivity software where you can go and have calls, meetings, and messages. So this means on software as a services, I have no option to apply my logic, no option to modify its patching, its detail, or is it as per me. I just can use the software with whatever features it has. I cannot modify that anyhow. So these are the varieties of services that we have on the cloud. Those are like infrastructure as a service, platform as a service, and software as a service. And it is important to know the differences between these 3 services. Sometimes if you're going for interviews, interviewer might ask these questions, and they might ask you whether AWS Glue is a platform as a service, or it's a software as a service, or it's a infrastructure as a service. Okay, so I just take a pause here if you have any questions.
Yeah. Hello.
Yes, please.
Yeah. Can you give one example for platform as a service? I didn't understand exactly the second word.
Okay. Okay. So platform as a service, if I talk about like the cloud environment, then we have S3, we have Lambda functions, we have AWS Glue, we have AWS Redshift. These things, you might go ahead and categorize them in the platform as a service. Okay. If I talk about AWS Glue, that means we can go ahead and write the logics for your data transformations, but we are not responsible for the behind the scene machines, their patching, their OS, how they are built, how they're accessing each other, how they are going to turn up, how they're going to shut down. We have no access about those things. So that's why these services where we can just go and write the logics. So if I say simple terms, where services where we can just go ahead and write our logics, we have no options to modify the content of that service, the quality of that service. That is going to be a platform as a service.
Okay. Okay, got it.
Okay, moving ahead then. So can I say that we can rent the resources on a console with a few clicks? This actually means when I click on, let's say, EC2 engine and I say, launch a virtual machine for me, actually or physically that machine is going to get launched on some data center of that particular cloud provider. Okay. It is just that I'm able to operate or work on that machine remotely using the interfaces of the cloud. Now, when I say data centers, these data centers are located physically in this world. Okay. And these data centers are actually divided into multiple availability zones. So one availability zone might have 2 or more than 2 data centers for any of the availability zones. And these availability zones are actually confined in one region. So this region is a physical area. Okay. If I just give up one example, AWS does have one region in India. Actually, now they have 2, one in Hyderabad, one in Mumbai. Okay. So basically, if I say in very simple language, in Mumbai, these guys have 3 availability zones located on 3 different locations. And on these availability zones, they have multiple data centers. Why we have this kind of architecture? So let's say I go ahead and launch one virtual machine, and that gets launched on a racks available on this particular data center here in one particular availability zone. And let's say due to some electrical failure, due to some bugs, due to some hardware failure, or let's say any region that can cause these issues, a data center goes down. When that particular data center goes down, where you have launched your application, that means your application is also down. Okay. Now, if I talk about real-time scenarios, let's say we are working for a bank and we have we have created our services on cloud, and that particular data center fails. This means no user can go ahead and access the banking application. They might not be able to interact with the website. They might not be able to withdraw the money or send the money. So to avoid this kind of situations, we create these layers. So actually it is the user who decides the high availability. Okay, these terms we are going to learn in the classes, the high availability, fault tolerance. Okay. So to make our service highly available and fault tolerant, we have the options to launch our machine in multiple regions, multiple availability zones. That means I can go ahead and say, okay, launch my machine on data center 1 and keep a copy in data center 2. So if a data center 1 goes down, I can still serve my customers from data center 1. And also keep a copy in data center 1 of the different availability zones. Just in case if complete availability zone goes for a toss, then I can still serve my user from data center 1 in different availability zones. And like that, we have multiple data centers, multiple availability zones, and multiple regions. So I could also say that launch one of the service or keep one of the backup in different availability zones, maybe US, Singapore, or any region that you choose. That means if complete availability zone goes down, I still serve my customers. Okay. This means to have fault tolerant application and to have highly available application, the cloud divides its data centers in multiple physical locations. These physical locations are actually connected via fiber cables, so the lag is not there. And this architecture help us to achieve highly available services. Okay. When we go ahead and launch highly available services, yes, we are going to get charged a bit more. Okay, if I'm launching something in here, and again on different regions also, then obviously going to be get charged more. And you can say almost all of the services have different layer of highly availability. Like by default, S3 comes with highly available features. It will create 3 copies of your files, 3 copies of your data, getting divided into a single region at multiple data centers and multiple availability zones. Okay, if you want, we can create a copy of the same in different region also. So don't worry about this part if you don't get it completely. We are going to be performing these tasks in practical from tomorrow onwards, and we are going to discuss about S3 in great detail. But yeah, if you have any questions about regions, availability zones, data centers, high availability, and fault tolerance, these are the four or five key terms. If you have any questions about these things, please go ahead and ask me.
Hello.
Yes.
Yeah. Here you said like availability zone is nothing like region, right? So,
no. So
is it region?
Okay. Okay.
Sorry.
Just a second. So you can say region you can compare to country, availability zone you can compare to states, and then data centers you can compare to cities. Like combination of cities creates a state, and combination of states creates a country. It's the same concept we are following here. Okay. So
okay, region is like a country, and the availability zone is as a state, and data center 192 is within the state in different cities. Is it like that? I mean, 2 different cities.
No, it's a single city. Okay, you can okay. It's a single data center in this particular availability zone. Okay, then these are different data centers in different availability zone. But it is just that we create copies in both data centers. So if I compare this with the city and state example, this means I do have a house in 2 different states and 2 different cities. Okay, you can say that. And in the case of natural disasters, I can shift to another house and survive there. It's kind of that concept. That means if one data center fails, you still gonna serve your user from a different data center. Okay.
Okay. My question is like for example, the availability zone. Let's take it as a Hyderabad. Okay. In Hyderabad, we'll have 2 data centers, right? For example, if you take the first availability zone, so why we want to maintain 2 data centers in same place? If there is any power cuts, as you said, or if there is anything happens, then we'll lose the connection with both the data centers, right?
Yeah.
As these 2 data centers are located in the same place and like in the same region.
So see, the power cut is the most least probable thing that is going to happen with.
I'm giving as a power cut, but anything can if anything happens. I mean,
see, idea behind here is to serve your customer. Okay, see, 2 data center means first of all you're going to have a more capacity. Okay, and it is also like if something happens, like it's not always possible that something happens same to both data centers. Okay, it might be a rack failure, it might be hardware failure in one of the data center only. Then you have the backups in a different one. It's just that, see, when we have this kind of situations, when we have 2 data centers in same availability zones, this we call availability zone level fault tolerance. Okay, this is one thing. We are talking about availability zone level fault tolerance. If one data center fails, another one is serving you. But as you mentioned, power cut can happen to both data centers at the same time. For this case, we have region level failure. That means complete region should be down to make sure complete region should be down. Only in that case, your application is going to be down. So in these cases, your application are still going to start from the data center of different availability zones. Okay, it's like dividing your hardwares in multiple layers to avoid this kind of fault tolerance or to avoid this kind of disasters.
Okay.
It's like we say in finance. Okay, don't go completely for FD, don't go completely for equity, and even if you're going for equity, don't go for one particular type of asset. You can go for mutual funds, you can go for stocks. Even in the stocks, you can go for multiple layers of the stocks. Even in stocks also, you can go for large, mid, and small, and even in the mid also, you can go for different varieties of companies. So it's like don't bet everything only at single place. Just spread out the things.
Okay, I understand. Like why I'm thinking is like what I'm thinking is exactly like within the one availability zone, like instead of maintaining 2 data centers, so we can maintain 1 data center. I mean, whenever we create more copies, obviously we have to purchase more hardware, right? So
Yeah.
obviously it will give a cost effect. So instead of that, we can maintain 1 data center in one availability zone and another data center. Anyways, if we maintain the another copy of our data in another availability zone, and as you said, if one availability zone goes down, then we can retrieve the data from the another availability zone as there is no latency and it is connected with fiber connectivity only. So why you want?
Okay, understand this part. First of all, these hardware, these actual destinations are created by Microsoft and Amazon. Okay, and these companies do not lack money. Okay, so that's why they go ahead and create this kind of architecture. Why they plan like this? It's their own choice. So more or less, it's like they wanted to provide you. Okay, they wanted to provide you the more options for a user. To provide you more options for the user, they went ahead with this kind of architecture. Now it's up to us how we want to do it. Whether I want to keep a zone level failure, whether I want to keep a region level failure, or whether I want to keep a multi-region failure. That is up to me as a user, how I want to use this. This is options available for you.
Okay. So in front end, like in the UI side, we can choose, right? Like
yes,
how many copies we want to maintain and
yes. For some of the services, we can choose. For some of the services, by default, they provide multiple copies for free.
Okay, all right.
Yeah, I mean, this is all from mine for today. On an introduction part, we are going to continue with the S3 part of cloud journey from tomorrow classes. And Ganesh, I think the time is 9 p.m. Just for the today, for some personal reasons, I had to shift it 30 minutes back. The time is actually going to be 9 p.m. Every day. And yeah, if you still have any more questions, you can ask those.
So any questions from anyone? Karthik, Vijay, Vishnu, Jayant?
No.
Okay, then if you don't have questions, then we can end the session today. So see you tomorrow by 9 o'clock. From tomorrow class will be 9 p.m. to 10 p.m. Okay. Thank you. Thank you, everyone.
Nice. Bye-bye.
Thank you. Thank you, everyone. Bye-bye.